In this video, we shall be looking at the circle theorems and answering some questions. The circle theorems are all about angles in circles. The first one we normally meet is this one. Angles in the same segment are equal. I think it looks like a bow tie, but you can be the judge of that. Our next theorem is the one most people remember. The angle at the centre of the circle is double the angle at the circumference. Here it looks like an arrowhead. But this theorem can come in many disguises. Move the points round and we have a reflex angle, but the theorem is still true. Or we can make a flag shape, or the lines can intersect, but the theorem is still true. A special case of this theorem is that the angle in a semicircle is a right angle, because that's half of 180 degrees. I think it looks like a bird. A cyclic quadrilateral is a quadrilateral for which all four corners lie on the circumference of a circle. The opposite angles in a cyclic quadrilateral add up to 180 degrees. Finally, we need to know about tangents. A tangent is a line which just touches a circle at one point, rather than intersecting twice or missing altogether. From any point outside the circle, you can always draw two tangents to the circle, and the distance from the point to the circle will be the same for both of them. Also, a tangent and a radius are perpendicular, i.e. they meet at right angles. Our final theorem is the alternate segment theorem. An angle between a chord and a tangent is the same size as the angle opposite the chord. I think it looks like somebody windsurfing in front of the sun, in which case the top of the sail is the same angle as the one by his or her feet. Now for some circle theorems questions. Question 1. For each of these questions we are asked to find x and y and give a reason for our answer to y. In this question, the angle at x is 83 degrees, because there is a large triangle which already has angles of 24 degrees and 73 degrees, and all our three angles must add up to 180. So y is 97. Why? Because x and y are opposite angles in a cyclic quadrilateral, and opposite angles in a cyclic quadrilateral add up to 180 degrees. Question 2. Ignoring the tangents for a second, we have our arrowhead, where x at the centre is double the angle at the circumference. So x is 160 degrees. Now we can work out that y is 20 degrees. Why? Well, since a tangent and a radius are perpendicular, we know three of the four angles in a quadrilateral, the two right angles and x, where y is the fourth angle. Note that since we have two right angles opposite each other in this quadrilateral, it's a cyclic quadrilateral but for a different circle. Question 3. Firstly, the triangle with x and 50 is isosceles, since two of the sides are radii of the circle. Two of the angles are 50 degrees, so x is 80 degrees. For y, we have our arrowhead in one of its disguises. X is the angle at the centre, and y is the angle at the circumference, so y is half of x. Y is 40 degrees, therefore, and our reason is that the angle at the centre is double the angle at the circumference. Question 4. We don't need to work out x first in this question, but if we want to, we have to use the arrowhead rule in another of its disguises. X is half the size of the reflex angle at the centre that makes up 360 degrees with the 74 degrees. 360 take away 74 is 286, and half of 286 is 143 degrees. Y is 37 degrees, and we are asked for two reasons, one using x and one not using x. We can use our answer for x because x and y are opposite angles in a cyclic quadrilateral, so they add up to 180 degrees. Alternatively, y is half of 74 degrees, because we have the third of our arrowhead's disguises, the flag. Question 5. X is in an isosceles triangle. Using the perpendicular tangent and radius theorem, we can deduce that the identical angles are both 25 degrees, and hence x is 130 degrees. As for the previous question, we have an obtuse angle at the circumference, which is half the reflex angle at the centre. 360 take 130 is 230, so y is half of 230. Question 6. We can use the windsurfing alternate segment theorem here, so x is 72 degrees. For y, we have at least two choices, both related to right angles. Firstly, the tangent and radius meet at right angles, so y is next to a 42-degree angle, and therefore y is 48 degrees. Alternatively, the angle in the semicircle is 90 degrees, meaning that the 42 is next to a 48, and then we can use the bow tie, angles in the same segment, to show that y is the same as the 48 degrees.